Welcome back. It was brought to my attention that we are up to 50 subscribers. Hello. Way to go. Keep learning well. And today we're going to, I want to do something special for that. Not tomorrow, but maybe on Monday when we have a few more people there. So day 41, I just want to continue looking at increasing, decreasing, critical points, concave up, concave down, inflection points. So I wanted to draw my attention to a problem I just made up because I think it'll work well for some interesting things happening. So here's what we have. We've got f of x equals 1/4 x to the fourth minus 4/3 x cubed plus 7. Okay? The first question I have for you is, what are the x values of the critical points of f, and then determine local max, local min, or neither. So again, we want to find the x values of the critical points of f. We want to determine if those critical points are local mins, local maxes, or neither. So first off, when we read this problem, when we see critical points of f, immediately what do we think? What we immediately have to think, we have to get to this point, is we have to say, okay, this is when f prime of x is 0 or undefined. So we're looking for f prime to equal 0 or to be undefined. Okay? So the first thing we want to do is we want to find those x values of the critical points, and then later we'll worry about determining local min, local max, or neither. So before I find f prime equals 0, I need to find f prime of x. So let's go ahead and calculate that. I'll change colors here. We need to be good at multiplying fractions really quickly. 4 times the fourth is 1, right? So we get 1x to the third minus 4/3 times 3 is 4x squared, and the 7 goes away. So there's our f prime of x. It simply equals x cubed minus 4x squared. What I want to do now is set this thing equal to 0. All right. Now, I know you solved some cubic equations in Algebra 2 and maybe in pre-calc as well. They're simple in this scenario. Cubics can be difficult to solve, but this is an easy one to solve if you can see what you can factor out. All right, what shows up in both x cubed and 4x squared? Well, that would be x squared. So let's factor that out. When we factor out x squared, we get x squared parentheses x minus 4 equals 0. That gives us two answers here. Right? We set x squared equal to 0, and we set x minus 4 equal to 0. When I do the plus or minus square root, I still get 0 both times, so I get x equals 0 as one of my critical points, and I get x equals 4 as the other. So those are my two x values of my critical points. So that's step 1 of the question has been completed. Now I want to determine if we have a local min, a local max, or neither at these points. Well, to determine that, I need to know how does f prime switch, or does it even switch, at these x values. So what I want to do is make an f prime number line and graph my two zeros. So I'm going to plot 0 here and 4 here. Now I want to test numbers around 0, or to the left of 0, between 0 and 4, and to the right of 4. So doing so, I'll test -1 first. I'm gonna use, you're welcome to use this. But I always like using a factored form just for testing. So I'm going to use the factored form of x squared x minus 4, because these are the same thing. So when I try negative 1, right, when I square negative 1, I'm obviously going to get a positive number. When I plug negative 1 into x minus 4, negative 1 minus 4 is negative 5. That's a negative number. And I have a positive times a negative, so I get a negative for this region. Next, I want to test between 0 and 4. I'll test with 1. So I'm going to go back up here. 1 squared is positive. 1 minus 4 is still negative. A positive times a negative is still a negative. Lastly, I want to check a number bigger than 4. So I'll use 5. 5 squared is a positive number. 5 minus 4 now is a positive number. A positive times a positive is a positive. So we see something interesting here that we haven't seen in our practices really yet. What type of critical point is x equals 0? Well, x equals 0 is neither a max or min, neither a local max or min. And our justification here is because f prime did not change signs. Okay. So we see we have a minus over here and a minus over here. F prime went from decreasing to decrease. Or f prime went from negative to negative, so f went from decreasing to decreasing. We didn't have a local max or local min. X equals 4 is going to be a different story. Okay. Again, I went from decreasing to decreasing. It's probably a terrace point there at 0. At 4, however, my function went from decreasing to increasing. That's clearly a local min. So x equals 4 is a local min, because f prime went from negative to positive. Okay. Good. My next question, by the way, I kind of want to take a look at a graph here. Let's see if we, on the graph, when I graph this thing, do I really have a critical point, but neither a max or a min at 0? And do I really have a local min at 4? I'm just curious to see what this thing looks like. Because I just made up the function, and I want to see what it looks like. So let's go to our y equals. Let's go ahead and type in 1/4 x to the 4. Again, I want to graph f here. Minus 4/3 x cubed plus 7. Okay. I don't know what window is going to be good here, so I'll just do zoom 6. Hey, that's a pretty good window. And what I see here is I do see a terrace point at x equals 0. That is a critical point there. However, it's not a max nor a min. Right, and it looks like there's going to be a min at x equals 4. I'm going to trace 4 just to see how low my window should go. Okay, so I'm just going to stretch my window down, my y min down a little bit. I'll go negative 30 just so I can see it a little bit better. And right there you see it. We see a critical point at x equals 0. That's neither a max or a min. And we see a critical point at x equals 4. That is a local min. Very cool. All right, let's go back. My next question for you is this. We're sticking with the same function. Let's see, how do I want to do this? So part B, we'll call it. B is going to say, on what intervals is f decreasing and concave up. And again, we want to justify. Okay. Now, the nice thing that I have here is I can use a lot of what I did in part A to help me on part B, right? It says, on what intervals is f decreasing? Well, we already made a nice f prime number line, and we could tell that f was decreasing from negative infinity to 0, union 0 to 4, right? And sometimes people include that 0. They'll just say negative infinity to 4. Okay, that's kind of debatable. You can do it either way on the test, and you should be fine. So we already know a lot about f prime, right? What we don't know anything about now is concave up. This is the piece that we don't know anything about. So again, when is f decreasing? I always like to do this ahead of time just to know what I'm doing. F is decreasing when f prime of x is negative. F is concave up when f double prime of x is positive. Okay? So that's the two things I'm looking for. The nice thing is I'm just going to copy my work down from part B. So I'm going to put my f prime number line right here. I had 0 here and 4 here. Okay, so I'm just going to use that again. And what I want to do is make an f prime prime number line. In order to make an f prime prime number line, an f double prime number line, I'm going to need to figure out where f double prime is equal to 0 and do some testing here. So I'm going to put that line, I'm going to line it up right underneath it, and then I'm going to do some work here with f double prime. Okay? So I'll fill in this line in a little bit. First thing I want to do is figure out what is f double prime of x, figure out when f double prime of x is 0, and then do my sign tests. So f double prime of x, this is where I'm talking about labeling is really important. It's nice to go up here to my work and have this labeled right here. So when I go back to do the second derivative, I know which function actually was f prime of x. So I'm going to do the derivative of x cubed minus 4x squared. Well, that's going to be 3x squared minus 8x. Okay, so there is my second derivative. Now I need to set this thing equal to 0. Okay, when I do so, right, I'm going to say, okay. Okay, so now I want to solve this thing for 0. I see an x in both terms, so I'm going to factor out an x. And when I factor out an x, I'm going to be left with 3x minus 8 equals 0. I'm going to set both of these things equal to 0. Obviously, x equals 0 is one of my points. The other point will be solving 3x minus 8 equals 0. I add the 8, divide by 3, and I get x equals 8/3 as my other one. So those are my two zeros on f double prime. Okay. Again, we don't know if they're inflection points yet. We'll have to do the test, but they're my candidates for inflection points. Not that that was part of this problem, but it's always good to consider that right now. So what I want to do here is I want to plot 0 and 8/3, and I want to plot them so they line up nicely with my f prime graph. Now 0 is going to be easy. I'll just make it directly underneath this 0. Now I have to think about 8/3. Well, where would 8/3 go? Well, I want to think about 8/3 as a fraction. Well, 9/3 would be 3. So it's a little bit less than 3. It's like 2.6 repeating. So I'm going to say, okay, this would be like 1, 2, 3. Somewhere right about here would be 8/3. It doesn't have to be perfect, but the better that is, right? The better we line that up, the easier it'll be to do our next task. Okay, so now what I want to do is I want to test numbers for f double prime to determine whether f double prime is plus or minus. So I'm going to use the factored form x and 3x minus 8 to test this. Okay, so I need to pick a number less than 0. I'm going to pick -1. X is -1, so this part is negative. 3 times -1 is -3, minus 8 is a negative number. Negative times a negative is a positive. Now I'm going to check the number 1, right? 1 is between 0 and 8/3. That switches this first term to a plus. 3 times 1 minus 8 is still a negative. Positive times a negative is a negative. And then I want to choose a number bigger than 8/3. I'll choose 10. 10 is positive. 3 times 10 minus 8 is positive. So I know my region out here is plus. So now what I want to do is I want to report. I always go back and say, okay, what am I looking for here? I'm looking for f prime to be negative and f double prime to be positive. Well, when I look here, in this part of the graph out here, right? That's exactly what I have. I have a decreasing function that's concave up because I know f prime is negative and f double prime is positive, right? And I have that. That stays true all the way until 0. My function is still decreasing at 0, but at 0, the concavity flips to concave down. Okay, and then that's going to stay. They're both going to be negative until I hit 8/3. Once I hit 8/3, I get back to what I want: a negative f prime and a positive f double prime. And they'll stay that way until 4, because at 4, f is still concave up, but f now switched to increasing. So here's what I'm going to say. Here's going to be my interval. I'll give this in a different color. Stands out a little bit. So my first region starts at -infinity and goes to 0. Union 8/3 all the way till 4. And that's my region. To justify this, I would say because this is where, okay, again, this is where f is decreasing, so I said this is where f prime is less than 0, and concave up because f double prime was greater than 0. Okay. These are tricky problems, especially trying to report like those overlap things. So stick with it, try hard with it, and we'll see you tomorrow. See ya, bye. Uh-oh, where's my thing? Oh, I almost forgot 2 chains. Whew, that was close. Bye. 50 subscribers.